Welcome to Statistics for Surveys, Session 3, Diagrams for a Single Variable, Segment 7, Frequency Polygon. The Cambridge definition of a frequency polygon given by Everett is a little bit complex, but the diagram in itself actually isn't. One easy way to explain what a frequency polygon actually is by using a histogram. So, given this histogram that uses frequency because all the bins are the same size, if we draw a dot in the middle of the top for each bar, then we connect those dots, and then if we remove the dots again and the bars, what we're left with is actually a frequency polygon. My personal problem with these is that almost all of the books will actually say that you have to draw them at the midpoints. And because this is continuous data, it now might actually suggest that the frequency for 2, if we go up, is about 5. Which clearly it can't be, because if we go back to the version with the bars, then you actually notice that it was 4 for this entire bar, and therefore the frequency at 2, cumulative wise, would be a maximum of 4. So I always find these a little bit misleading to some extent, but okay, this is what the definition says to do, so that's what we'll do. On the next slide, I'll show you how you can actually draw one without having to draw a histogram first. So let's say we're given a table with the ages and the frequencies. Then the bins we're using, all of these are known as the lower bounds of the bins. So that's why you find them up here. And all of these are known as the upper bounds, and that's why I've set them up here. Now the height and the height of the bins will actually be, of the dots in this case, will be at the frequency. And the position on the horizontal axis will be done by the midpoint. Now the midpoint, as you can see from this formula, is simply the lower bound plus the upper bound divided by 2. So first, for the first point, we take a 0, and then we actually add the 10, which will give us 10, and then we divide it by 2, so we actually get 5. So the first point will be at the position of 5, and then with a height, in this case of the frequency also being 5, at 5. So that's where the first dot will be. The second one will be with a height of 7 at the horizontal position of 15. So here's 15, and then if we move up to 7, we'll actually get this point up here. And we can do that also for the other points, for the other bins, and then we simply, as you can see, have been done here already, connect the dots to get the frequency polygon. On the vertical axis of a frequency polygon, you actually see what I've used so far is the frequency, also known as the absolute frequency. You could also use the relative frequency. Then it would still be considered a frequency polygon or a relative frequency polygon. However, if you use cumulative frequencies or cumulative relative frequencies, you actually get another type of chart which is known as an ogive, which will be discussed in the next segment. A final remark on the frequency polygon is that so far I've actually only drawn midpoints and connected them of bins that I actually had. Now some will argue that you should actually anchor the polygon, the line, eventually to the horizontal axis. You can do this by imagining another bin from 8 till 10 at the end, and the midpoint will be of course a 0 because there were no people who had scored between 8 and 10, and then again connect that line as well. We can do the same at the beginning, so imagine a bin going from -2 till 0, connecting the line. However, -1 might actually not even be feasible, so if these are integers, positive whole numbers, then a -1 is a little bit odd. So some therefore then suggest to actually place the dot at the intersection with the y-axis and then only use that line segment. So there are a few variations on this, so check your own textbook what it is they actually prefer to do. Of course we remove the dots and the bars, but this would be an alternative way of actually drawing the frequency polygon.